All right, everybody, welcome back. We are on the learning packet number 2. So the second learning packet, day 1, and this is the math, the skill assessment part. And the first question asks us to solve the problem with the equal groups model. So what I've got going on here is I have some groups. This is a group. This is a group. And this is a group. What I need to do is I need to change this into a groups of statement. So how many groups do I have circled in purple? I've got 3 groups circled in purple. And each group has 4 in it. So I've got 3 groups of 4 going on right here. Now we need to take that and we need to turn that into a multiplication sentence. And a multiplication sign is the same as saying groups of. So if we just have our 3 and say groups of when we see the multiplication sign, we've got 3 groups of 4 written like that. And to solve the answer, all you need to do is go in and count how many circles that makes in all. All right, so that's what they're looking for number 1. Number 2, it says how many 6s are in 24, draw a picture. And you've got some choices here. You can do an equal groups model like this and just make groups. Let's see, let's thicken that up a little bit. So if I go in, I can do it like this. I've got 1, 2, 3, 4, 5, 6. That's one group of 6. 1, 2, 3, 4, 5, 6. Now I've got 2 groups of 6. 6 and another 6, that makes 12. I need to keep going because I'm trying to find out how many groups there or how many 6s there are in 24. So I need to keep going. If I make another group of 6, I now have 18. I can write those underneath. This is 6. 6 more makes 12. 6 more makes 18. So I still need to keep going because I haven't made it to 24 yet. So I'm going to make another group of 6. And I had 18. This is 19, 20, 21, 22, 23, 24. Now I have 24 dots. So the question is, how many groups of 4 did that take? So if we come back over with our pencil and a new color, I've made 1 group of 6, 2 groups, 3 groups, 4 groups. So it takes 4 6s to make 24. And when they say draw a picture, this is what they're talking about. They want you to draw out a picture. Another way to do it would just be to skip count. Like you saw me do up there, I can go like this. 6, another 6 is 12, another 6 is 18, and another 6 is 24. This also counts as a picture, so let me change the color. There we go. It's a separate picture. I would count this as a picture. It's not quite a picture as much as it is a strategy or a method, but skip counting would work here as well. So you can either draw this picture to illustrate that there are 4 6s in 24, or you can go ahead and write your numbers, your 6s, skip counting, to illustrate that there are 4 6s in 24. Either one of those will work. The next one, number 3, says, Cole had 7 bags. He placed 9 strawberries in each bag. How many strawberries did he have? So the first thing that I notice is I have the word each. And we know when we see the word each, we're probably multiplying or dividing. But it always helps to go back and read everything in the story. Cole had 7 bags. So he's got groups. My bags are my groups. And then it tells us there are 9 strawberries in each bag. So I know he's got 9 in each group. And when you have groups and some in each group, This is definitely a multiplication equation. So I'm going to make my Math Mountain. The top should be my total. Down here should be where my groups are. And in this case, my groups are bags. And over here should be my in each group. So based on the story information, Cole had 7 bags. My bags are my groups. So I'm going to put that in my circle. Those are my groups. He had 7 bags. And there were 9 strawberries in each bag. This is my in each information goes here. 9 strawberries in each bag. And now we just need to figure out the total number of strawberries. And when you know the 2 smaller numbers but not the total, you multiply to figure that out. So when you write it, you're going to write it as 7 times 9 equals. And at this point, you have some choices. You can count 9 sevens, you can count 7 nines, or you can, if you remember our method of our nines, write out your nines. I'm not sure if I can do it in a text box, so I'm going to go ahead and write it out. Remember, you can do 0, 1, 2. Oh, I can't do this in a text box. Let's make this a little bit neater. Right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then right next to it, remember you're going to come back and you're going to write 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Now, you have all of the answers to your 9s that you need. And if I'm trying to find the 7th 9, then I'm going to go ahead and say this is my first 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7, and there we go, is right here. Fastest way to do your 9s. But remember, that only works with your 9s. It's a trick for the 9s only. All right, let's go on to number 4. Kim has 24 stickers. She wants to give 6 stickers to each of her friends. How many friends can she give stickers to? So I'm going to come back over here, and again, I'm going to highlight key information. I see the word each, and each usually means I'm either going to multiply or divide, but I want to go back and make sure I know my information because sometimes they can be tricky. Kim has 24 stickers, and she wants to give 6 stickers to each of her friends. And a lot of kids may say, hey, Mrs. Knight, that sounds like subtraction. And you're right, except that it's repeated subtraction. And what I mean by that is she's giving 6 stickers to each of her friends, which means she's going to give away 6, and then she's going to give away 6, and then she's going to give away 6, and she's going to continue giving away 6 until her stickers are gone. And yes, that is subtraction, but in 3rd grade, we say, hey, when you're giving away the same number every time until you have nothing left, that's division, right? So we're going to go ahead and set up our Math Mountain. Math Mountain, because I saw the word each, I'm going to set it up. I know that the top is my total. I know that the circle is where I put my groups. And I know that the square is where I put the number in each group. So I just need to figure out, okay, what goes where? Let's start with the 24 stickers. 24 stickers is the total amount of stickers that she has. So I'm going to put 24 up here in my total. She has 24 stickers. Then I'm going to decide where my 6 stickers to each of her friends go. Are those my groups, or is that the number each friend gets? In this case, my story, my groups are my friends. And I don't know how many friends there are because the question says, how many friends? I don't know. If my friends are my groups, I don't know that yet. So I'm going to put an F there. I don't know how many friends she has, but I know she gives 6 to each friend. So I'm going to put that there. And now I need to set this problem up. 24 is my total. And when you know your total and you're trying to find a missing factor, then we need to divide. So I'm going to set it up. 24 divided by 6 equals, and I'll come back in and write my division sign because I haven't bought the extended version of the program that I'm using, so my division sign is locked. So we'll just draw that in. 24 divided by 6 will equal the number of friends. So now you just have to count by sixes until you get to 24. And you can write those out if you want to, or you can look up here. Remember, we did this in question number 2. So you should know how many sixes make 24, right? So I'll leave that one to you. All right, number 5. Number 5 says, question A. Just so you guys know, A, B, C, and D, they're just question A, question B, question C, and question D. The A, B, C, and D are not part of the question. So question A for 5, 5A is blank times 5 equals 40. Well, you're going to count by 5s until you get to 40, and you're going to tell me how many 5s it took. Question B, 3 times blank equals 9. Well, you are going to count by 3s until you get to 9, and you're going to tell me how many it took. Now remember, for C, you've got blank divided by 9 equals 45. And it completely looks like this is a division problem, right? Except that, remember back to when we were in class, we had questions like this every Friday on the test. When you see a division problem, but you are missing the big number, remember this would be the top of my math mountain. This isn't division. If you don't know the top of your mountain, you are multiplying. So it looks like division, but it is really not. And you guys have your 9s written here if you did them with me. So 9 times 5, you should know the answer to because you guys know your 5s. But if you have forgotten, get your 9s and check it out. How much is 9 times 5? Because remember, it looks like division, but it really isn't because you are trying to find the total. And to find the total, we multiply. And on the last one, it's 20 divided by 5. So again, you're going to count by 5s until you get to 20. The difference between C and D is that on C, you're multiplying because I did not know my total. On D, you're going to count by 5s until you get to 20, which is dividing, because I do know my total. So I'm not going to multiply these two numbers. I know my total, and I'm going to divide by 5 until I get there and say how many 5s it took. C, I did not know my total. That's why I am multiplying. All right? Now let's move on to 6. 6A, 6B, and 6C. 6A, these are the properties of multiplication, you guys. When you look at 6A, what I want you to notice is this part right here where it says 3 times 5 is equal to blank times 3. Now, most kids, they want to go, oh, 3 times 5 is 15. I'm going to write 15 right there. Nope, stop. Don't do that. And if you did it already, erase it. And here's why. 3 times 5 is equal to blank times 3. If you tell me that a 15 goes here, then you're telling me that 3 times 5 is the same as 15 times 3. And no, it is not, because 3 15s make 45. And 3 5s make 15. That is not the same thing. So what you need to look at really carefully is this part where it says 3 times 5 is equal to blank times 3. They want you to use the commutative property here, you guys. All they're doing is switching them. All they've done is they've taken this problem, 3 times 5, and they've put the 3 here, and they want you to put the 5 here. They want to know that you know that 3 times 5 is the same as 5 times 3. 3 times 5 equals 5 times 3. That is what they are saying here, you guys. Just commutative property. I didn't even have to multiply. all I did was switch my numbers around. Okay.